All right, we're continuing on in factoring quadratic equations. The only difference today from the other day is that the x squared is actually going to have a coefficient on it. Okay, that's going to add an extra step when we factor into a product of two binomials. Remember, all these quadratics will factor into a product of two binomials, just like that. So it says, for two integers m and p, they're going to have a sum of b, just like the other day, except they're going to have a product of a times c, and not just c. Yesterday we just found factors of c that added up to b. Now we got to take a times c and find factors that add up to b. And then the extra step after that is that we're going to write it, we're going to split up that b term, and we're going to factor by grouping. Okay? It might look a little confusing with that algebra right there, but let's talk through it here. I'm going to take this polynomial right here, this quadratic, 5x squared plus 27x plus 10. When it gets in factored form, it looks like this. Okay, so I want to look at the factored form, and I'm going to go back to an expanded form, and hopefully we can kind of see where this is coming from. So I take 5x times x for 5x squared, 5x times 5 for positive 25x, 2 times x for a positive 2x, and 2 times 5 for a positive 10. Okay, if you notice, I got my 5x squared, my positive 10, my positive 10. Well, what happens is this b term, this 27x, we want to split that up. So like we said, we're going to take a times c now. So we're going to take a times c. So 5 times 10, which is 50. And then we find factors of 50 that add up to 27. And in this case, we found out it was 25 and 2. That worked out. And what happens is we split this 27x into our two factors, a 25x and a 2x. So 25x and a 2x. Because if I add 25x plus 2x, that gives me 27x. So that's why I'm allowed to do that. Well, then what happens is we group these, group the first two, group the last two, and then we factor like we did in our first section. So I'm going to pull a 5 out of this first binomial, 5x actually, and we're left with an x plus 5. And I'm going to pull out a 2 out of the second binomial, and we're left with an x plus 5, which is good, right, because we have a common binomial here now. So I can write that as a product of two binomials. 5x plus 2 times x plus 5, which we said was our factored form. Okay, so it might be a little confusing still. Let's do a couple more examples and see if that works out. So now that we have a coefficient on our quadratic, we have to use our a times c. We have to go a times c, which is 5 times 10 to give me 50. Right, now I got to think of factors of 50 that add up to 27. Well, this is just what we did, isn't it? And we took a look at that one, and we found that 2 times 25 worked. So we keep the first one the same. We split that bx, that 27x, into our two factors we came up with. So a 2x and a 25x. And it doesn't matter where you put which one. I like the 25x first because then I can factor out that 5x like we did, plus 2x plus 10. And then just like we did before, right? We grouped and we factored out. I'll just go through this quickly since we just did this to get our final answer of 5x plus 2 times x plus 5. Okay? So let's look at the second one. Well, when I look at this, I could immediately jump into my a times c, right? And go through what we just did and group them. But if I look at all three terms, I can factor something out of there right away. If you notice, all of them have a 4 that can be pulled out, right? There's a GCF of 4 in all three terms. So I'm going to go ahead and do that. I'm going to pull that 4 out. So I get x squared plus 6x plus 8. Well, this thing makes things nice, right? Because I already know how to factor a quadratic when there's no coefficient on my x squared. All right, I can split that into a product of two binomials by using my factors of c that add up to b, right? And I know it's going to be x and x. And if I take a look, factors of 8 that add up to 6 would be 4 times 2. So 2 plus 4 gives me 6. So I got plus 2 plus 4. Well, I already pulled out that 4, so I got to keep that 4 there. And I'm done. Okay, so I don't even have to use this method that we did in the first one. I didn't have to take that a times c, because when I pulled out a 4, I'm left with what we did yesterday, factoring when there's no coefficient on that x squared. Okay, so you might end up using both, whether the a times c or going back to what we did yesterday. Let's get back to the other a times c method again. Okay, so I got a coefficient on my x squared, so that means I got to take a times c. And if I look, I can't factor anything out of this 24x squared minus 22x plus 3. There is no common factor. So I take my a times c, 24 times 3, and I get 72. And I'm going to make my x here. So factors of 72 that add up to a negative 22. Well, I'm going to need a negative times a negative, aren't I? Because I want factors of 72 that add up to a negative 22. Well, I don't need negative 1 times negative 72. Those aren't going to add up to that. Even my next one, negative 2 times negative 36. That's not going to add up to a negative 22. Let's try the next one. Negative 3 times negative, what do we got, 24? We're getting closer, aren't we? And we got negative 4 times negative 18. Oh, that looks like it works. Negative 4 plus negative 18 is negative 22. So those are my two factors. Remember, I don't jump into a product of two binomials here. We don't do that. That's only if there's no coefficient on my x squared. I have a coefficient here. So we gotta group, right? I gotta split up this negative 22x into my two new factors I found. So I rewrite my 24x squared. Now I got a minus 4x and a minus 18x. Remember, it doesn't matter what order you want to write them in. Minus 4x minus 18x. I split up that negative 22x there. And I still have my plus 3. And we go ahead and we group first two. Before I group the last two, I want to change to adding the opposite. Okay, so now out of the first one, let's pull out a 4x. And we're left with 6x minus 1, right? 4x divided by 4x is 1. So I want to get my inside to be 6x minus 1. So I should probably pull out a negative 3 instead of a positive 3 here. So I'm going to pull out a negative 3, so I get a positive 6x minus 1. That's why I want to pull out that negative 3, because now our binomials match up here. So I'm going to write this as a product of 4x minus 3 times 6x minus 1 for my final answer. And there we go. So make sure, if we have a coefficient on our x squared, like that 24 there, I have to take a times c, find factors of that add up to the b term, and I got to split it up. Right? How I split up to that negative 4x and minus 18x. And then group. That's our new thing when there's a coefficient on the x squared. Let's take a look at the next one here. So coefficient on the x squared. I can't factor anything out of that trinomial. So I got to take 3 times 5, which is 15. And factors of 15 that add up to a positive 7. Well, actually, this is a negative 15, isn't it? Because 3 times negative 5. So one's going to be positive, one's going to be negative. So factors of negative 15 that add up to 7. Well, I got negative 1 and 15. That doesn't. 1 and negative 15. Nope. I got negative 3 and 5. Now that adds to 2. I got 3 and negative 5. Now that adds to negative 2. Well, I don't think there's any more factors, are there? So nothing works here, right? Nothing is going to be factors in negative 15 that add up to 7. It's not going to work. So what we call this, when I can't factor anything out of here, and then there's no factors that A times C that add up to your B term, when I can't do anything, we say this is a prime polynomial. We say it's prime because I can't factor anything. It's like a prime number. There's no factors for prime numbers besides 1 in itself. So it's a prime polynomial because I can't do anything.